Atmospheric pressure can crush you in less than a second, but you may never even notice it. Atmospheric pressure is the weight of the air in our atmosphere, pressing down on us from all sides. It's a force that's always present, but often overlooked, until it becomes a life-or-death situation. Imagine being in a room with the air pressure equivalent to being at the bottom of the deepest ocean, over 36,000 feet below the surface. The pressure would be crushing, with the weight of an entire skyscraper pressing down on you. But that's not the strangest part. Atmospheric pressure can also be extremely unpredictable. A change in pressure can trigger thunderstorms, tornadoes, and even hurricanes. In fact, the drop in atmospheric pressure that occurs before a storm can be as much as 1 millibar per minute. To put that in perspective, the atmospheric pressure at sea level is around 1,013 millibars, so a drop of just 1 millibar would be equivalent to a pressure change of about 0.1%. But what causes this sudden drop in pressure? The answer lies in the complex interactions between the atmosphere and the oceans. When a storm system forms over the ocean, it can pull in moist air from the surface, creating towering clouds and releasing massive amounts of energy. As the air rises, it cools, and the water vapor in the air condenses, forming droplets that make up the cloud. But as the cloud grows, it can become unstable, and the water droplets can start to fall as precipitation. This process can repeat itself multiple times, creating a cycle of storm development and intensification. And then something unexpected happens. The storm system can merge with other weather patterns, creating a monster storm that can wreak havoc on entire cities. For centuries, scientists have been studying the complex interactions between the atmosphere and the oceans, trying to understand the intricacies of storm development and predict when and where these monsters will form. One of the key factors that determines the intensity of a storm is the amount of moisture available in the atmosphere. When the air is full of moisture, it can create towering clouds that can reach heights of over 10,000 meters. But what happens when the air is too dry? The result is a storm that's devoid of moisture, leaving behind a trail of dry, barren land. Imagine a desert storm, with sand swirling in every direction, but no precipitation to speak of. It's a strange and unfamiliar sight, and one that scientists are still trying to understand. The study of atmospheric science is a complex and ever-evolving field, with new discoveries being made every year. From the intricate dance of atmospheric circulation to the formation of massive storm systems, there's still so much to learn. And yet, despite the many advances that have been made, we still have a long way to go before we can fully understand the mysteries of the atmosphere. One of the biggest challenges facing atmospheric scientists is predicting the formation of severe weather events. While we have made significant progress in understanding the underlying factors that contribute to these events, there's still much work to be done. The development of new technologies, such as advanced radar systems and high-performance computing, has helped to improve our ability to predict severe weather. But even with these advances, predicting the timing and location of these events remains a daunting task. The stakes are high, with severe weather events having the potential to cause widespread destruction and loss of life. For every second that passes without warning, lives are put at risk. And yet, despite the challenges, atmospheric scientists remain committed to their work, driven by a passion to understand and predict the complex interactions of the atmosphere. Their research has the potential to save countless lives and protect communities from the devastating effects of severe weather. So what can we do to stay safe in the face of severe weather? The answer lies in staying informed and being prepared. By monitoring weather forecasts and following evacuation orders, we can reduce our risk of injury or death. It's a message that's been echoed by scientists and emergency management officials for decades. And yet, despite the many warnings and alerts, some people still fail to take the necessary precautions. It's a tragedy that can be avoided, and one that serves as a reminder of the importance of staying informed and being prepared. The study of atmospheric science is a reminder of the awe-inspiring power of nature and the importance of respecting its fury. As we continue to learn more about the atmosphere and its many mysteries, we are also reminded of the importance of preserving our planet for future generations. It's a message that's been echoed by scientists and policymakers for decades. And yet, despite the many advances that have been made, we still have a long way to go before we can fully understand the complexities of the atmosphere. The journey of discovery is ongoing, and one that requires the collaboration of scientists, policymakers, and the public. By working together, we can unlock the secrets of the atmosphere and create a safer, more sustainable future for all. And that's the story of atmospheric science, a journey of discovery that's still unfolding. If you found this fascinating, subscribe for more incredible stories like this. Want more mind-blowing facts? Hit subscribe and join our journey of discovery.